Yeah, thanks. Hello, everyone. Thanks for the intro. So, I realized that I was at an in-person event previous 2 days. I realized that most of the audience come from language service provider side. So I may be able to start with sharing a little bit of context on what we do to explain how we relate to enterprise localization. Because we're not an LSP, we're not a TMS, we're not a machine translation vendor. Then I'll talk about some of the issues in the localization process which may prevent being successful with machine translation. And then I briefly cover our approach of making this sort of health checkup of the localization stack, how we get the test data, how we run tests and diagnostics, what we prescribe, and how we expect things to get healthier. So overall, we build tools which help to select right machine translation vendors for particular enterprise use cases, such as localization or customer service, then customize and evaluate those machine translation engines and connect them through our integration platform to a specific software systems. In case of localization, of course, it's translation management systems. And then the same engines get connected to all other use cases across the company. And this will also collect feedback from those translations to improve MT, much along how Kirti Vashi described it on the first conference day in his talk about translation in the age of customer experience. I would just add that customer experience, I believe, is not the only goal here. And another important goal is corporate social responsibility and being able to build an inclusive work environment for all company employees with respect to their native languages. And by the end of the day, our goal is to enable companies to translate all they need for internal and external processes, both by dramatically reducing cost of the human touch for post editing, but also by translating all other content through raw machine translation. And here I will focus specifically on the traditional localization use cases, which involve either adding or radically improving machine translation part of the localization stack. And what does it take to benefit from adding machine translation to the workflows? It turns out that getting the best machine translation is not enough. And here are some other things to consider. So first, there are maybe not empty bottlenecks, misconfigured translation management system, inconsistent translation memories, wrong attribution of translation memories to projects, and they may cause altogether much more waste of resources than just lack of MT. And moreover, since you will want to use these translation memories to train machine translation afterwards, you really want to fix this part first. Then another point of possible efficiency is a fuzzy match threshold. Typically, you expect to take in context exact and high fuzzy matches from TM, and then instead of low fuzzy matches, you use machine translation. And if this threshold is off in any direction, then most likely translators are over editing. And some companies may think it's a problem only if they pay extra. If they don't pay extra, they don't care. Well, it's not true, because if translators do more than expected in editing, translating, or even have high uncertainty around the editing effort, it will show itself either in the prices for translation or in translation quality. So then another thing to check is machine translation. If machine translation is already used, is it priced properly? And you, of course, will face it when you improve machine translation quality and you want to understand how your discounts change. But even before that, you need to make sure that you pay fairly for post-editing or charge fairly for post-editing compared to how you pay or charge for editing translation memory fuzzes. And then if you're already applying post-editing and machine translation, you may want to know where it's failing and what's the room for improvement. Because depending on that, you may decide either to invest or not invest in the improving machine translation. And then finally, you ask a question, can content be machine translated at all? Or perhaps translators, in your case, mostly transcreate, and no amount of training machine translation of these transcreated strings will fix it. So how all those questions are answered the best? Well, honestly, I don't know. But we needed to answer them. Otherwise, when we improve machine translation quality for our customers and connect them to their TMS, we risk not delivering the expected ROI. Also, we are primarily engineers at Intento, so we thought, okay, let's just check how much we can get automatically by dumping some data from TMS system and crunching some numbers. And it turns out that we can get a lot this way. So let's start with the data. We will take it straightforwardly. It's source text, what was meshed, what was leveraged or machine translated, then match type, final text. And sometimes there was also information on the project or specific post editor doing the job. It's always helpful to have it to do some slicing of the results. And in terms of the match type, it's typically various translation memory leverages, then repetitions, and then machine translation. And despite the simple data format, we were surprised how hard it is to get such data from many TMS systems. And if it's hard to get this data, it means it's really hard to run this type of analysis, and it's really hard to understand what's going on. So I'd recommend discussing this as early as possible with the TMS vendor, or even putting it as an RFP requirement. So once we got the data, the first thing we do is duplicate analysis. It seems very simple. So of course, we see many full duplicates across TM leverages, and that's what we expect. That's how TM works. Other duplicates require more attention. So if you see source-only TM duplicates, meaning that source was the same, but final text is different, then it may mean that it's just context-dependent translation. But in practice, we see that this is the case in very few occurrences. And this may also indicate there is a certain inconsistency in how translation memory leverage is edited. And this typically indicates certain major issues with the localization process, quality assurance process, or TMS configuration, which needs to be addressed before adding machine translation. So second, full empty duplicates. And you may think that it's all right. That's base intuition, that it's logical that same source gets the same machine translation and it's post-edited in the same way. Well, it's not. Because after the string was machine translated and then edited, what we expect it to come next time from translation memory or as a repetition from TMS. So this doesn't happen. If it's still counted as MT, well, you're paying for post-editing the same strings many times. And the percentage of such duplicates will tell you exactly how much. Just to give you an idea, in one of the checkups for a customer, we found this number to be 60%, meaning that they were paying 60% extra for post-editing just because of this type of misconfiguration. Then there are source-only empty duplicates, which is basically it's about the same like full duplicates, but during the post-editing process, final translations got different. And again, in some very, very few cases, it's about the context. but in many cases it's just about because when people had to post-edit, different translators had to post-edit the same string, they decided to post-edit in a different way. And that results in feeling inconsistent translation memory, which in turn will damage trained MT engine, and overall means that the whole content is inconsistent. So after we're done with the duplicates, we'll look at the distribution of words across different match types, both overall and in several slices by segment length, by project. And it's pretty essential to assess expected gains from improving machine translation. Also here you may see anomalies in translation memory matching across different projects, which may lead to subsequent investigations as maybe some labeling, tagging of TM metadata is wrong. However, don't be misled that, like in this case, improving machine translation will affect only this part, which is being post-edited from machine translation. It's not, because when you improve machine translation, what you expect to change the threshold. So as machine translation gets better, you're sending more words towards it. So the impact will be bigger. And properly configured localization process enables organization get efficiency compared to translating texts from scratch over and over. And the main goal of our checkup is to assess what's this efficiency today and what's the room for improvement, so we you know how much you may invest. And to do that, we need to somehow calculate how much effort goes into translations. And one thing we know that we cannot really use TER as a number for that, because many studies show that TER and editing effort are not really correlated. So instead of that, we identify several types of post-editor activity as objectively as possible. So we identify perfect strings which are not edited, only reviewed, corrected strings with some slight changes, punctuation, spacing, capitalization, formatting, then right translations, which are very significant changes, and the rest just goes to post-editing. And we apply certain effort coefficients compared to human translation. Typically, those are identified together with specific LSP vendors who's doing this job, but those are average numbers, which typically we see. And it's fair to say that post-editors perform such activities not only when they review machine translation, they also do that when they review translation memory matches. And the lower fuzzy score is, the closer this mix of these activities will be to machine translation post-editing. So if we look at distribution of those activities around the words of those segments, and we multiply that just on those coefficients, then we'll get overall localization effort compared to just translating everything from scratch. And of course, this effort reduction comes from many, many sources. Translation memories, TMS, and source content translatability, and MT performance and post-editor qualifications. Like in this, for this specific picture, this overall effort is about 36%. And now what we do then, we look at different slices of this data to understand which of those components may be a bottleneck and what we can do to reduce this effort. So first, we can look at how those activities are distributed across different match types. And here's a pretty typical picture when in context matches, it's almost exclusively review. And then increasing amount of corrections, post-editing, and right translation as fuzzy match score gets lower. And here you already may have an intuition that, okay, MT may be actually better than this 85% fuzzies. But if we do this effort calculation for each of these TM matches, then we see precisely that machine translation here indeed looks to be better than 85% fuzzies. And there's another signal from that most likely, if we're paying here for post-editing more than for editing 85% fuzzies, something is wrong, because the amount of effort is clearly much bigger for editing those fuzzies. So we have something to discuss about the pricing right away. And also we may want to change the threshold so that instead of doing this lots of editing for fuzzies, we actually post-edit machine translation. So then we're starting to dive into specific issues. Like suppose we have seen that some of the projects are outliers in terms of the TM match editing effort. Like you see here, there's quite big variance across different projects how TM matches are edited. Or just overall, we see that editing effort is higher than expected. So what we can do then, we can just pull, top 100 segments by edit distance and analyze them. And typically, it enables finding 80% of possible issues. Typically, all issues we find about translation memories are related to either improper labels on TM, which gets them matched to wrong projects. And then it's not an issue for in-context matches, because, if the context is different, it will not match. It's all right. But it's a huge problem for fuzzy matches, because fuzzy matches get totally irrelevant. And then also sometimes we see things like fragmented segments apply to parts of the sentences, and that's also something to be fixed. Then we look at specific machine translation issues. So we apply the same approach like for TM. However, here we need to iterate. So we look at the segments with the biggest edit distance. We identify the biggest empty issue. Then we apply the same process for the remaining segments, because some of the empty issues may be so big that they affect a large number of segments and they just prevent finding other issues. So the most prevalent issues we found are as follows. It's do not translate issues when something which should not be translated was translated. And we, in our process, we automatically identify them. We automatically build a glossary to be applied on top of machine translation to fix those problems. Then there was opposite issue, false DNT, or something not translated why it should have been translated. So here the remedy is either training machine translation, because you cannot fix it with typical empty glossary. There's also some other types of glossaries which are more like pre-processing of text before sending it to machine translation, which also help with that. Then quite often we see issues with formats and numbers between different, between the United States and Japan. There's quite a bit difference in how sizing of cloths represented. And that's typically, again, they're easily automatically identifiable, and they can be fixed either by MT training on such segments, especially when it's about that in one language you have digits and in another language you should have numbers and words. Also, it can be fixed with automated post-editing, which we also apply in such cases. Then there may be issues with encoding and text formatting, which typically sort of because of their certain filtering misconfigured or file processing misconfigured on TMS side, maybe fixed this way. Then there are typical machine translation issues, sort of what would you expect? So those are omissions, additions, mistranslations, junk translations. And here, typically, you either train for the empty engine or you change the engine. And we have about 40 empty platforms connected, and sometimes indeed it's easier to change the horse than to train it. And finally, also this way we identify source quality issues. So those are segments which where we see that machine translation produces reasonable, straightforward translation, while a post editor changes it significantly, effectively transcreating the straightforward translations further away from the source. And in most of the cases, that's not because there was a desire to produce a highly localized copy in this language. In most of the cases, it's because the source text in English was not really translatable because it has some American idioms. For example, if you use like home run, you can use it in marketing text in the United States, but you can translate even to Japanese, but it will be some baseball term. It will not be understood. So the trick is that you cannot really train machine translation on such segments. Well, at least you typically cannot do domain adaptation on them. You cannot train on a little bit of text. And moreover, since those are not straightforward translations, training on them may even ruin the engine because it will think that actually those words have different meaning. So there are a couple of ways to solve it. So one way to solve it is change the approach to writing content so that copywriters create more translatable content. And that's typically faces strong opposition because, of course, like on American market, copywriters want to create content for American audience. As a second possible approach is to take translation into the first language, non-English language, then just take this most edited segments, back translate them to English, and use that to create international copy. And then use it to translate to other languages. It has very good impact on reducing the post-editing effort. And then there are some new ways to deal with that through automatic transcreation using GPT or some other large pre-trained models, but that's a topic for a separate talk. So based on these issues we identify, we typically suggest several action items to fix either before improving machine translation or alongside of it. And some of them require updates to TM configuration, others concern translation memories and other parts of the stack. And as we discuss, some of the issues go upstream to content creation. Here you may see most popular fix, but frankly, every new localization setup we see, it adds something to think about. So last part, which I want to talk is what happens next. So then when those issues are addressed, process improves. So, and on next checkups, you see how it improves. So if TMS and TM issues are fixed, it reduces both amount and variability of post-editing of translation memory leverages. So it lowers the cost effectively or raises the quality depending on what you optimize. Then improving machine translation actually reduces post-editing effort for machine translation, and it helps you to both change the threshold to send more words to post-editing and also add certain reasonable logic on how you discuss pricing for this post-editing, since you see how it compares to what you've been paying for or charging for editing fuzzies for years. And then effectively it means that you're sending more words towards post-editing and you're paying less for that, which, like in this example, reduces overall translation effort from 36% to 26%. And this is Japanese, so it could have been more. But even that basically means that you can translate 40% more content on the same budget, which is, I think, pretty great for most of the companies. So as conclusions, what I wanted to say is that we see that bottlenecks in the localization process can cause much more issues than absent or inefficient machine translation. And many such bottlenecks are overlooked by different involved parties, which is expected because it's the, and I think Istvan yesterday was talking about that in very right words, that every end user has their own ways to assess ROI and how to relate to the business processes. And this type of reporting should be owned by the end user in most of the cases. We see this simple approach, simple meaning it's automated. There is very, very low human involvement in this process, which we run. It helps to identify those issues, fix them, estimate room for improvement and possible gains for improving machine translation. And if you do it regularly, like with health checkups, it helps track how machine translation overall process improves. Well, you can run to new data to show how it works, or you can do it yourself. Again, it's very straightforward and simple. Thanks. That's it. Happy to answer the questions, or just send them. Yep.
Wonderful. We have a question already from the audience from Alexander. What issues with MT do you think can or will be resolved within the next couple of years, and how will it influence the post-editing productivity?
Thank you. That's an important question. I think we had just about the whole panel about that. That, you know, from our perspective, and that's maybe it's a bit biased, but basically what we see that what you can do and what you absolutely should do is to do more post-editing to get more human edited data to train better engines, and sort of turning every dollar spent on post-editing into dollar spent to improving the quality. This is the default way to go, but frankly, it works so far because there are situations when the perceived quality depends on how context relevant translation is. Are you using the right tone of voice? Are you addressing the right gender of the person who is reading this text? And this is something you cannot fix by training, but you can fix it by other models around machine translation. Well, that's what we do at Intento. But also what you can fix it, interesting, even if you have those models, you typically run into a specific problem that the whole localization process and sometimes IT infrastructure is built in a way that you don't have access to this metadata. Because you use XLeaf somewhere, there is no place for it in this XLeaf. So it requires changing not the machine translation part, it requires changing that business process. And finally, and that's, I'm talking a lot about that because that's on my plate right now. This thing with content translatability and adjusting content to a different culture, not just straightforwardly translating it, it just cannot be solved by machine translation. And it's quite important when we speak about human in the loop and being centered on humans, we often think about end users, we think about translators, but we exclude copywriters. They're like outside of the equation. Let us humans fix what they did. Well, that's not true. And what I see, most of the things I see, they're not about improving machine translation itself. Most things I see about improving how we work with it is actually bringing these guys who write content closer to us. Also with technology, with things like GPT and other, but just also as human persons, just bring them closer, help them to write content in a way that it's easier to translate. Yep, that's that's my take.
And I think we might have time for just one more question also from the audience, from Alexander. Where is migration to post-editing accepted more painfully by translators, in Europe or in the US?
It's a good question. I may not be the best person to answer because I'm in the US, and I see, frankly, I see more pushback from European peers, where they may just have, I don't know why, just maybe because in the United States people more, easygoing. But I think it's actually for maybe MLV can answer this question, like the LSP, but I don't know.
Well, thanks for everything you've shared today, and our time's out, but I hope that those of you in the audience who still have questions for Konstantin can find him during the online conference. And thank you so much for this presentation. Thank you to everyone for being here.
Thank you so much. Thanks for coming. Yep. See you next events, hopefully in person. Bye-bye.